Namaste, dear students. Are you fine? Yeah. Today we are discussing about the hydrocarbons which are made up of by double or the triple bonds. In our earlier class, we discussed about the saturated hydrocarbons. What are the key structure or key features of saturated hydrocarbon? Can you remember right now? Yeah, is you have just remembered that the saturated hydrocarbons are those hydrocarbons which are made up of the single bond edge between carbon and carbon. But today we are discussing about the other types of the hydrocarbon. You can see over the screen here, and what differences do you find over these two compounds? Can you write in your copy? Yeah, if you go through the first one, you can see these two carbon atoms have been bonded with the double bond. That means first bond, the second bond. That means double bond. And this carbon has only two hydrogen atoms, and this carbon also has the two carbon atoms. But if you go into the another structure, that means in the second one, then what do you find here? Yeah, the carbon atoms have been bonded with the single bond. Just you can see the single bond here, this one, C and C. What is the bond between? Then how many bonds do you find over these two carbon atoms? Yes, single. So these are the differences. If you count the total, if you count the hydrogen that atoms, then you will find there are altogether 6 hydrogen atoms. Then there are only 4. This is the one. This is one difference. As well as the second one, or the second difference is the number of bond at the first compound is the double. In the second one, you will find this single. Only one bond has been seen at between carbon and carbon. So these are the differences you can find. Then if you have just written these things over your copy, then what is the difference? Then what type of compound are they? That means, are they the similar compound or the same compound, or are they in the same family? Obviously not, because the hydrocarbon which is bonded with the double bond, they are called the unsaturated, but the second one is the saturated. So in today's class we are discussing about the unsaturated hydrocarbon. So this is the topic for today's class. Okay, be ready to discuss or to interact with me, please. So the hydrocarbon which are bonded with the two bonds, they are called the alkenes. As we have discussed, as you have learned about the alkane, that means they are the single bonded hydrocarbon. The double bonded hydrocarbons are called the alkene. Yes, you can see here. So we are talking about this one, and this is also known as olefins. Commonly they are used to say they are the olefins. So as we have just denoted by the alkenes by the formula Cn as 2n plus 2. For the alkene, we used to write this formula, that is Cn as 2n. That means the number of hydrogen atom is double of the number of carbon atom present over the compound. Okay, you can see this example. In this structure, you can see this black ball indicates the carbon, as well as the white ball indicates the hydrogen. So altogether there are 2 hydrogen atoms in a single carbon, but this carbon has been bonded with the another carbon with a double bond, and this carbon also has the same, that means 2 hydrogen atoms. You can see here, this is the model. Okay, you can see here, the blue ball indicates, or this represents the carbon atom, one carbon and another. Then you can see double bond. Is it difficult to see double bond? Yeah, one stick has seen over this one, as well as another stick has been shown at the bottom. So altogether 2. That means these 2 carbon atoms have been bonded with the double bond. This is only the model. The same the structure you can see over the screen. So this is the model. It can be represented by this one. That means this carbon, and these are the hydrogen atoms. So this is, I think, this structure is not new for you. It is quite easy. I think you can easily understand this one. And another one, you can see propene. So as you have seen the model of the ethene, you can make the model of propene also. Prop represents the 3 carbon atoms in the hydrocarbon. So you can see one carbon atom, another one, as well as third one. So altogether 3 carbon atoms have been seen here. So according to the formula CnH2n, how many hydrogen should it consist? Obviously, CnH2n means the double of the number of carbon atom should have got the hydrogen atom. That means, so this is the hydrogen 1, 2, 3, 4, 5, 6. 3 carbon atoms as well as 6 hydrogen atoms. So this is the model, or this is the molecular formula or the structure of what? The propene. So structurally, this propene can be represented by this structure. So this hydrogen, this just you can resemble with these 2 structures. You can obviously find, you can obviously understand the structure of, or the molecular structure of the propane. Similarly, in the butane, so but represents the 4 carbon atoms present in the hydrocarbon. So these blue balls, first, second, third and fourth. These blue balls represent what? Yes, carbon. And the these balls, these smaller balls, they represent what? They are the hydrogens. If there are 4 carbon atoms, then how many hydrogen atom should it consist? Yet, can we count? 1, 2, 3, 4, 5, 6, 7, 8. So it means it is related with CnH2n. 4 2s are 8. This is the model. It can be represented by this structure. The bond between carbon atoms can be shifted from this first carbon to second carbon, or it can be in the second carbon, this carbon between this one as well as this one also, or this or this. So it represents the the bond between carbon and carbon is double. So this is about the olefin, or this is the structure of one of the olefins. That means alkenes. So by the same way, we can make the structure of pentene also, then hexene also, and so on, because the higher alkenes can also be written by the same way, because the pent represents the 5 carbon atoms. So then if ene suffix is being used, then you have to write the double bond between carbon atoms, but the position of the double bond can be either of any carbon atoms. Okay, this is all about alkenes. I think this is quite helpful for you to recognize the alkenes as well as this is all about the information about alkenes. So we are moving ahead towards the alkyne right now. Alkynes, in this name you can see YNE. YNE represents there are 3 bonds between carbon and carbon atoms. So the general molecular formula to represent the alkyne is CnH2n minus 2. That means twice the number of carbon atom, and it should be subtracted. Okay, the 2 should be subtracted from the twice of the carbon atoms, so that it will be the number of hydrogen atom. So you can see the structure. This is the model. The black ball represents the carbon atom, as well as the white ball represents the hydrogen. So the structure looks like this. Okay, so I have made this structure by the help of clay. Okay, there are 2 white balls as you have seen in the screen, and these 2 carbon atoms, or these black balls, represent the carbon atoms. So these have been connected with the 1, 2, 3. There are 3 sticks between 2 black balls. So these 3 sticks represent the number of bonds present between these 2 carbon atoms. So the hydrocarbons which are bonded with 3 bonds between carbon and carbon, they are called the alkynes. How do you recognize the alkynes? Yeah, by looking the number of that bonds between carbon and carbon. If you see the 3 bonds between carbon and carbon, then to which category or to which group do you keep such type of hydrocarbons? Yes, obviously it is under the alkynes. So we are talking about this type of alkynes. So this is the general representation of alkyne, and this is the ethine. So eth represents the 2 carbon atoms, and YNE represents the number of bonds. YNE represents 3 or triple bonds. So this is ethine, and structurally it can be represented by this way. So it represents the 3 bonds between carbon and carbon, and the hydrogen is being connected with the carbon with a single bond. So this is all about the ethine. And now moving ahead, you can see this another structure. It is a bit very smaller bond between this carbon and this carbon. As I have already talked about this, that the black ball represents the carbon. So you can see the 3 bonds between carbon and carbon. So if you see the triple bond, then what do we call for this? Yes, alkyne or the ethine. So this is the model. Then it can be represented structurally by this way. Yes, hydrogen, 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 this hydrogen, as well as this hydrogen is another one, and this carbon and this carbon. Okay, so this is the propane. So Y and E for the triple bond. I am just reminding you to recognize the propanes or the alkynes, as well as prop represents the 3 carbon atoms over the hydrocarbon. So this is about the propane. So you can prepare such type of models at your home yourself by taking the different types of the materials. Materials can be of any kind. I will discuss at the last while giving you a project work. In the same or the same that class, that means alkyne, I am just taking another example, that is butane. What does this YNA represent? Can you say? Yeah, YNA represents the 3 bonds or the triple bond between. Have you seen triple bond between the carbon atoms? Yes, obviously. First, second, third. That means this represents the carbon atom, this also represents the carbon atom, and there are triple bonds. So this is what? This is the butane, because but represents the 4 carbon atoms between 4 carbon atoms in a hydrocarbon. And structurally, it can be represented by this structure. Hydrogen, carbon, just you can resemble with these 2. I'm just restate these 2 structures, because I have already discussed such things. Just relate these 2 structures. So this is all about the butane. Okay, another term is homologous series. Before defining this term, let's discuss on the information given in the table. The name of the compounds have been given, like methane, ethane, propane. They have the molecular formula CH4, CH3, CH3, another one CH3, CH2, and CH3, and they do have the molecular weight 16 AMU, 30 AMU, as well as the 44 AMU. If you just study these that structure as well as the molecular weight of the different compounds, then what is the difference do you find over these structure? Please write in your copy. Okay, obviously the molecular weight of first compound and second compound, what is the difference between these 2? 30 minus 14, sorry, 13 minus 16, then you will find the difference. How much? Yes, 14. As well as if you subtract 30 from 44, then you will find the same difference. If you go through the another one, that means butane, then how much difference do you find in the molecular weight of the consecutive compound? Obviously the same. Then this type of the hydrocarbon in which the molecular mass is differed by 14 AMU, as well as if you go through the molecular formula, then you will find if you add CH2 in this, if you add CH2 in this, obviously you will find CH3, CH3. Okay, as well as if you add CH2 in this, then what do you find? Obviously this one. So this is the thing that I am just going to discuss about the homologous series. If you find the difference of the molecular mass by 14 AMU, as well as if you find the difference of the consecutive that hydrocarbons by CH2, then what is the term to be term related to this? What is the relationship between between the compounds of the same family by these two that points? That means by CH2 as well as 14 AMU. Yeah, I think you already have known. This is called the homologous series. So they are the homologous series, as well as methane, ethane, propane, as well as if you go into the butane, obviously you will find the molecular mass plus 14, as well as you will get the another structure or another molecular formula for the butane would be CH2 would be added at the middle. This would be the butane. Similarly, if you go into the pentane also, you will get the same difference, as well as the by the structure also, as well as by the molecular mass also, you will find the similar differences. So this is called the homologous series. This is the definition. The group of the hydrocarbon in which one member is differed by 14 AMU or CH2, as I have just discussed. This is all about the definition. For your convenience, I am just defining the term for your convenience. So similarly, I am giving another example. Three compounds have been given here. They are CH3OH, then CH3, CH2OH, CH3, CH2, CH2OH. If you find the difference between the molecular formula, then what is the relationship between these first and second one? If you omit or if you remove this one, then what will be the product? Obviously first one. If you omit or if you remove this CH2, then what will be the product? Obviously this one. That means first compound and second compound through the molecular formula, they are differed by the CH2. As well as the differences through the molecular formula between second and third is again CH2. As well as what would be the molecular mass? Can you guess? Carbon has 12 and hydrogen has 1 for each, then altogether 15, and oxygen has 16, 31, as well as hydrogen is 1 altogether. What is the molecular mass of this first one? 32. Yes. Can you calculate the molecular mass of this ethanol also? Please try your best to write the correct molecular mass for this. Okay, what is the product? Yes, you have written. What is this? Okay, 46. Then what is the difference between 46 and the 32? Obviously 14 again. And similarly, if you go into the another one, then obviously as I have just discussed, through the molecular formula, it is differed by CH2 as well as in the molecular mass. Then what would be the difference? If you deduct 46 from or subtract 46 from 60, what would be the difference? Okay, they do have the same difference between first and second as well as second and third. So it also represents the homologous series. This is the homologous series of what? The alcohol, because this OH represents the alcohol. So the homologous series are those that term or those thing which are present in the hydrocarbon, in which one compound is differed by 14 AMU, as well as one compound and another, the relationship between one compound and another compound is CH2 by what? That molecular formula, and 14 AMU by their molecular mass. This is all about the homologous series. Are you enjoying in today's class? Yes, because this is quite new term for you. This is all about the that hydrocarbon, and okay, this is just very simple mathematical calculations for the to find the differences both in AMU as well as to find the difference between the molecular formula from one hydrocarbon to another one. So I am just talking about the another term, that is the alkyl radical. For this, I am just trying to write some example to make you understood about the alkyl radical. CH4, if one hydrogen atom is subtracted from this, what would be the result? Obviously, you will get CH3. As well as if you deduct one hydrogen atom from ethane, what would be the product? Obviously, it would be CH3, CH2, and one bond is incomplete. So for this, if one hydrogen atom is being removed, this is called from methane. If one hydrogen atom is removed, the remaining product is called the methyl. As well as from ethane, this is the structure of ethane, and if this hydrogen is being removed from one hydrogen from ethane has been removed, then obviously you will get this structure, this product. Then what is it? If one hydrogen has been removed from the ethane, then the remaining product is called the ethyl, and they do not have the completely bonded that structure. That means one bond is still incomplete in each carbon atoms. You can see here. This is obtained by removing one hydrogen atom from the methane, as well as this radical is being obtained by removing one hydrogen atom from the ethane, as well as if one hydrogen atom is removed from the propane, then what is it called? Yes, this is called the propyl. They are called the radicals: methyl radical, ethyl radical, as well as the propyl radical. Propyl radical. If you remove one hydrogen atom from the butane, then what is it called? It is called the butyl radical. Yeah. If you remove one hydrogen atom from the pentane, what is the remaining product? Yes. Have you written the pentyl? Yes, this is the correct answer. As you have seen that by removing one hydrogen atom from any alkanes, we can get the respective alkyl radicals. So, how do we recognize the radicals or the alkyl radicals? Okay, according to our discussions that we have just made, obviously it is all about the remaining product after the removal of one hydrogen atom from each alkanes. That's all. Okay, if you know all about these things about the alkyl radical, it is enough for you for this grade. Okay, moving ahead, I am just talking about the another term, that is the functional group. Okay, according to the dictionary, what does this function mean? Function means which does the work. Then in the chemical reaction also, in the chemical reaction of hydrocarbons also, the reactive part of any hydrocarbons are being represented by some special groups or from special that atoms over a compound. For example, you can see here CH3, then OH, as well as CH3O CH3, as well as CH3 COOH. So if you go through these three compounds, then what type of differences do you find here? Okay, in the first one you can see this is OH group, but in the second one you can see this oxygen atom has been bonded with two other carbon atoms from one side, okay, in either sides, as well as in the third atom, or sorry, third compound, you can see there is okay, that COOH. These are the special groups or the special atoms present over the hydrocarbons. they are the very reactive part of the hydrocarbon. During the reaction, these part take part in the reactions. So they are the reactive one. So these are called the that functional groups. So to define the functional groups, the atom or the group of the atoms that represents the characteristics, then in the first one, this represents the alcohol. If you see the other hydrocarbons with OH, then what does it represent? This is the alcohol. It also represents the that nature of the hydrocarbon, as well as the that it is the very reactive part of the hydrocarbon also. As well as in the second one, O has been bonded with 2 carbon atoms. Then what does it represent? This represents the ether. Okay, as well as in the third compound, COOH. This is the different part seen over the compound. So this represents the that hydrocarbon of the carboxylic acid family. So these are the special or the that group. These are the special atoms or the group of atoms which represents the specific characteristics of the organic compound, as well as they do have the very reactive. They are the very reactive side of the hydrocarbon also. So this is all about the things to be discussed in today's class, and I'm just going to discuss about some questions related to today's topic. So you can see which of the following is unsaturated. According to our discussions, what is the basis to recognize the hydrocarbon unsaturated? You can see, do you see the number of hydrogen atoms? No. Do we see the number of carbon atoms? There are 2 carbon atoms. Do we see the number of carbon atoms in the third one also? You can see there are 1, 2, 3 carbon atoms. But in the fourth one, what do you find here? Obviously, you can see the between carbon, this carbon as well as this carbon, you will see the double bond. So double bonded as well as the triple bonded hydrocarbons are called what? The unsaturated. So out of these 4, which one is the correct option according to the question given above? Obviously, this fourth one. In which option did you tick while discussing? Fourth, correct. Okay, you are correct. Okay, next one. Which of the following is correct about carbon and carbon bond number in between alkane, alkene and alkyne respectively? The carbon and carbon bond represents, the M represents alkane, as well as N represents alkene, as well as O represents the alkyne. So you have to just relate the this second column with the third one. Is according to the question, M should have got the it should be matched with what? The molecular formula of what? The alkane. That means M should be related with what? Or what is the that molecular formula of alkane? Yes, Cn as 2n plus 2. If this option, out of these 4 options, if M is related with 3, yes, M is related with these 3, as well as N. What does this N represent? Alkene. So what is the relation? What is the general molecular formula of alkene? Cn as 2n. So if you connect, if you just relate this N with 2, so in the option number C, you can find the correct option. That means M3, this is the alkene, N2 alkene, as O1, this is the general molecular formula of alkyne. So what is the correct answer? Okay, option number C, this is the correct option for this question. So moving ahead, please look at the structure or the structure given in the screen. Choose the correct option according to the given molecular structure. So 2 molecular structures have been given here, CH3OH as well as CH3 CH2OH. According to our today's discussion, these 2 compounds have the same functional group, then they are differed through CH2 group. Do you remember? Yes. Okay. So by studying these 2 molecular formula of the 2 compounds, then which of the options given below are the correct? Is the correct? Okay. These 2 are the unsaturated hydrocarbon. Is this the correct one? No. because we do not see any double bonds at between two carbon atoms. So this is not the correct option. Actually, in the option number B, these two have different functional group. Do you see any different functional groups over these two compounds? No. They do have the same alcoholic functional group. Option number C, these two have the differences by 14 AMU. Think once. What is the molecular mass of CH2? Carbon C, 12, and 2 hydrogen atoms, 2. 12 plus 2, 14. It may be the correct answer. And then the fourth one, these two have same alkyl group. If this OH group is removed, what does it remain? CH3. If this OH group is removed, then what is remaining part? CH3, CH2. This is methyl, this is ethyl. This is also not the correct answer. Then what is the most closest or the most correct answer? Out of these 4 options, C. Option number C. This is the correct answer because they are differed through the molecular mass 14 AMU. Okay. Next question. Write general molecular formula of alkene and alkyne. So while writing the general molecular formula, according to our discussions, alkene has the general molecular formula CnH2n, as well as alkyne has the molecular formula CnH2n minus 2. These are the correct answers for the question. So please write the answer of this question number 5. Why is ethane called unsaturated? What is the reason behind this? Because if you write the molecular structure of ethane, then you should write double bond at between 2 carbon atoms. If there are 2 bonds at between 2 carbon atoms, obviously it can add some other species. So it is unsaturated. This is the reason that ethane is called the unsaturated. Okay, in the question number 6, explain about homologous series and functional group with example. First, you have to define what is homologous series as well as what is functional group, as well as you have to add some examples to beautify your answer. Like homologous series are the compounds or the compounds of the same family. They do have the that difference by CH2 group, as well as they do have the differences of 14 AMU, and you can give some examples of that alkane or alcohol or any other that hydrocarbons. As well as in the functional group, you have to define and you can write the example as we have discussed in our class. So moving ahead, you have to differentiate between some terminologies like saturated as well as unsaturated. So to write the differences between saturated as well as unsaturated hydrocarbons, you have to write at first definition. What are called the saturated hydrocarbons? Those hydrocarbons like alkanes which do not add some other that species while making the reaction, as well as if you go through the bond, carbon is bonded with the single bond in all other species. There is no that double bond or triple bond at between the carbon atoms. They are called the saturated. In contrast to this, you have to write the that definition of unsaturated, like the hydrocarbons which do have the double or the triple bonds. They may add other species like hydrogen as well as other halogens as well as other species. Such type of hydrocarbons are called the unsaturated hydrocarbons. And you can give some examples also. And number B, alkene and alkyne. First you have to write the structure of alkene, or you can write one of the examples of alkene. You can write the differences between the general molecular formula of alkene as well as alkynes also. And you can write the number of bonds present between alkene as well as alkynes also as a difference. So this is the way to write the difference. If you write that definition, you have to write the definition for the next one also. If you write about the number of the bonds at between carbon and carbon, obviously you have to write the that number of the bond between carbon and carbon atom in the next column also. Next one, alkane as well as alkyl radicals. This task is for you. You have to write the difference yourself, because about the differences as well as about all the informations it has been discussed in our today's class. Okay, I hope you all write the differences between all of these things. Finally, as a project work, I have brought a question for you. Prepare a model of ethene, propane, and ethyne. In your previous class, you made the structure of what? Of the alkanes. But in today's class, you have to prepare models of alkene as well as the alkynes. Like you have to prepare the that ethene, model of ethene is like this. You can use any materials like flour, you can use like that clays as well as other papers, and any materials, any suitable materials you can use, but you have to make the models of these things which have been displayed over your screen compulsorily, and you have to submit to your teacher. Okay, I hope you all enjoyed in today's class, and we will meet in the next class, and you have to do all the that task that I have given to you and submit your teacher. Have a good day ahead. Thank you.